Okay, everybody, welcome back. We're kind of in the home stretch here of our Chapter 10 on hurricanes and cyclones, and we've already talked about the conditions that are required for hurricanes and cyclones to form, and also some of the hazards that they bring. Sections 6 through 9 are going to start with some of the natural service functions of cyclones and hurricanes, like some of the good that they can actually do. One of which is, I guess, it's kind of obvious, but it's a big source of precipitation, especially for places inland that don't normally get precipitation. All right, if an average hurricane produces 1 trillion gallons of water a day, that's a good amount of water for places, especially that may not otherwise get very much water over the course of the year. So precipitation is a big thing. Redistributing warm air from the tropics. All right. Well, since air circulates around, that's one of the things that drives hurricanes. But it's good that air circulates around, because otherwise it would stay all in one place. And we want that energy to be distributed all around the world, not just stay right in the tropics near the equator. There's also some good things they do for ecosystems as well. Winds and waves can stir up all kinds of animals and microorganisms and stuff, and bring up nutrients from the bottom. I'm thinking in particular things like this is phytoplankton right here, and there's zooplankton. All these little things, little teeny tiny organisms that live, that can be found in the deep ocean. Well, hurricanes tend to stir them up and redistribute them around, and make them more available to other parts of the ocean, and also can move them great distances across the ocean as well. Hurricanes can also, they can knock down trees, dead trees in coastal forests. These trees right here were killed in a tsunami, and they would otherwise just be kind of taking up the space right here. But what hurricanes can do is actually knock those down and kind of accelerate the decay process. I mentioned right here that waves break apart some corals, which you read that for a second and you think, wait a minute, it doesn't sound like a good thing. It sounds like a bad thing. I mean, coral is good. Why is that good that it's breaking it apart? Well, an interesting thing can be done with coral. These scientists right here are doing what's called coral planting, and what they do is they cut coral into little pieces, and then they plant it in little concrete pads, if you will. All right, and then they have them grow underwater, and each of these corals actually grows because it's being given room to grow. And then when these are all big enough, they take them and they replant them back to the coral reef. So you've got big, healthy coral growing. So sometimes breaking apart coral can actually help it to grow more. So all these things can contribute to can help various different ecosystems. It can contribute to the perpetuation of ecosystems. All right. So human interaction with cyclones. Well, the problem with humans and the cyclones' danger level to us is the fact that we put ourselves in danger. I mean, our population really grows in coastal areas. And it used to be that the population in coastal areas was really high because, well, that's the only way you could sail back and forth between continents. Of course, we don't need sailing ports anymore, but now coastal areas have just become very desirable just because they're pretty. All right, people like living near the ocean. So there's a huge, huge population density in coastal areas, especially in the United States. Take a look at this next map right here. This is not in your notes, but I found this, and it's kind of a neat infographic. All these spikes right here are areas of population density. And you see here in New York City, that's this big tall one right here, 23,000 people per square mile in New York City. That's right on the coast. Down a little bit is probably Philly. Down a little bit more is probably Washington, D.C. Up here is Boston. All right, you've got Miami down here. Over here you have Los Angeles and San Francisco, and you have Seattle up here. So a lot of these spikes are near water. So a large part of our population, even down here in the Gulf, you have, I think that's Houston right there. Large part of our population is right next to water, and so they're right in harm's way when it comes to hurricanes. And it's also not just the number of people, but also just the things that people build Coastlines can be made more vulnerable by what people build. Sand dunes are really a good thing, but when we tear sand dunes down and put houses on them, sand dunes usually can protect coastal areas if they're big enough from storm surges and hurricane waves. But if those sand dunes are torn down or replaced with buildings, well, that doesn't have that effect anymore. Sea walls and bulkheads are just great big walls that are supposed to contain coasts. Well, they do in one regard, but in another regard, they can actually reflect waves and cause coastal erosion somewhere else. So that's another bad thing as well. And not just that, but also building materials, poor building materials. All right, it's no secret that coastal, let's say, beach houses aren't the best built. I mean, yes, they are built many of them on stilts and stuff, but they're not the most heavy duty. I mean, they're made for kind of like warm weather, kind of fair weather conditions, and not really to do major sheltering of people inside. And so they're not built to be real heavy duty. And so if you've got poor building materials in these coastal homes, they can be really susceptible to being knocked down when you have a hurricane come through. And then, of course, there's always the global warming, the fact that we believe that people have contributed to global warming. All right, so we do that by putting more what we call greenhouse gases in the air, by burning more fossil fuels and putting carbon dioxide in the air. And that global warming, I mean, we know that hurricanes are fueled from warm water. And so we think that maybe global warming could even contribute to a greater intensity and frequency of hurricanes in the future, all because of what we're doing to contribute to global warming. Not only that, but it also contributes to rising sea level. If the ice caps are melting, that water's got to go somewhere, and so the sea level would rise. But global warming is definitely we believe, a contributor to the frequency of cyclones and hurricanes. Okay, so how do we mitigate cyclones and hurricanes and extratropical cyclones? Well, the fact remains that we can't prevent it. Right? Maybe we could be doing a better job of reducing global warming and helping that way, but these storms will still come regardless. And so what can you do if you can't prevent it? Well, you can reduce property damage and loss of life by informing people, by getting out of the way. Right? And forecasting certainly helps with that. Issuing advisories, that certain areas of the coastline need to be evacuated. That's the way you get people out of harm's way. You can't prevent the threat, but you can move them. You can move people elsewhere. Building codes, enforcing building codes is another thing. Like I said before, not all coastal buildings are built all that great. Well, if you enforce certain codes, buildings can withstand more pounding from hurricanes and will probably be able to last longer. And I should also point out that these are for hurricanes, but also for extratropical cyclones too. Remember, extratropical cyclones are the ones that occur at a little bit higher latitudes, or the ones that come through where we live. All right, but remember, they can produce torrential downpours and thunderstorms and lightning and tornadoes and stuff like that. So all these practices up above can also apply to extratropical cyclones as well. So what does a forecast entail? I mean, no doubt you've seen weather forecasts on TV, but for hurricanes, there's a lot of information that goes into a certain forecast. First of all, if it will make landfall. All right, well, that's a big one right there because we live on the land. So is it going to hit us or is it not? That's a big factor right there. Where and when it will strike, of course, that's another big player as well. And so that way you know how to inform or which people to inform whether they should evacuate or not. Wind strength, how big the hurricane is, how much rainfall it is. Also, how fast it's tracking. If the hurricane is tracking very slowly, that rainfall is going to affect a lot more because it's going to have all that rain in one area. And also whether or not there's a storm surge, in most cases there is, and how big the storm surge is. So all these are parts of forecasts when it comes to hurricanes and cyclones and extratropical cyclones. There's a U.S. Hurricane Center based out of Miami, Florida. And I can't tell you where the Canadian Hurricane Center is, but I can tell you that there is one. And maybe the threat is a little bit less for them, but we work in concert with our Canadian friends to do forecasts that are actually accurate. If a hurricane watch is issued, that means a day and a half from now you're likely to get a hurricane. It's likely to hit 36 hours. Okay, if a hurricane warning is issued, well, that means within a day, within 24 hours, a hurricane is bearing down on where you live or your area if you receive that warning, and so you need to take precautionary measures. All right, so what kinds of things do we use to forecast? And there are a whole lot of tools that meteorologists use to make accurate forecasts, and they weigh all these things. Weather satellites, of course. Now, we're used to the day and age of weather satellites and just thinking that, well, we can just look down from space and see which way things are going. But satellites are only one part of making accurate forecasts. Aircraft, if you saw, which I think you did, the Storm Chasers video we saw where the plane actually flies into the hurricane. All right, well, it takes a lot of measurements as it goes into the hurricane. So NOAA, I should point this out to you. NOAA is the National, it's actually a really long name, National Aeronautic and Atmospheric, sorry, my handwriting's pretty bad right there, Association. Okay, that's basically kind of like the it's the main weather entity in the U.S. government. Okay, wait. Oh, did I have that wrong? I'm sorry. No, I'm thinking of NASA. It's not National Aeronautic. It's National Oceanographic. Oh goodness, I'm trying to give you too much information right here. NOAA, National. I'll do this in blue. Oceanographic. Messed that one up. Sorry. NOAA, National Oceanographic and Atmospheric Association. I said it was a long name, so no wonder we call it NOAA right here. But NOAA is a big player in using planes to fly out and measure hurricanes and help with predictions. Doppler radar. We talked about Doppler radar when it came to tornadoes. All right, Doppler radar. What that does is it determines which way. It determines if wind is moving away from you or towards you. All right, and so it can give you sort of a cross-section of a storm, even if the storm has not quite reached here yet. Weather buoys, these are very helpful because they give us information out in the ocean. All right, and so you don't have to have a person right there, but the buoys can do that. They can give you sea height, wave height, pressure, temperature, all kinds of things, and they help us collect information about storms as well. And finally, computer models. Believe it or not, one of the most powerful computers in the world is dedicated specifically to weather prediction. There's a lot of various different factors that weigh into determining what the weather's going to be like on a certain day. And so computers help us with that as well. Okay, so here's Hurricane Charley in a radar image, or a Doppler radar image. All right, and so what happens is the radar bounces off of falling rain and it shows us which areas have the strongest falling rain. This red right here and the orange and the yellow, and which areas are weaker. So that's what you might see if you were looking at a Doppler radar image of a certain hurricane. All right, and of course, as the further out a hurricane is, the less likely you know exactly where it's going to go. So let's say a hurricane is right here. Okay, well, there is a kind of an area of error, kind of this wedge-shaped area here, where it could go in the next few days. All right, well, a day later, that area widens and then widens again. So it's like, well, we're pretty sure it's going to be in here somewhere. And at some point, even though this was the original track, you could see that, okay, generally speaking, it stayed within that track, but here it kind of went out and then it came back in and then kind of went out again. So this is Hurricane Charley right here. The further out you go, the more error there is. That is, the more margin of error you need to have an accurate prediction. Okay, so how do you predict storm surges? Well, there's also a couple different factors and tools that meteorologists use as well. Wind speed, all right, because remember we said wind speed, which is really, wind speed and fetch are kind of the same thing. Remember we said fetch is wind moving over water, causing it to pile up and create the storm surge. And of course, the faster the wind speed is, it contributes to that fetch right there. But also water depth as well. All those things can play into determining how high the storm surge is going to be. But also the topography of the ocean floor and the coastline is going to play a big part as well. Depending on what the bottom contours of the ocean are and what the coastline is like, that will help us determine how bad the storm surge is going to be when it actually does arrive. And also computer models as well. We seem to be using computers for everything, and this is no exception. And so, as we get information about the wind speed and fetch and that kind of thing, we can use computer models to determine where the storm surge is going to be at its worst. Okay, now this picture may actually look kind of familiar to you. Not this picture itself, but this picture, I believe, was taken from Google Earth right here. All right, and so this is the same picture right here, but we did this in class this year where we actually took a plane, P-L-A-N-E, a flat plane, and colored it blue and actually raised it up a little bit. This was simulated using the same kind of thing in Google Earth. So this is sort of like a simulated storm surge of the city of Galveston, Texas. Well, you could do that really with any coastal city. I think we simulated it before with flooding and with not with hurricanes, with tsunamis. But you could do the same thing with a storm surge as well, because a storm surge, to some degree, acts much like a tsunami. So as much as we've gotten better at predicting hurricane tracks and strength and where they're going to go and so on and so forth, that's good, but the downside is the coastal populations continue to increase. The people continue to move towards coasts because, well, it's just pleasing to live there. And so we get better at predicting, but people get better at getting in the way of storms, and so that's kind of the catch-22 right there. So hopefully our predictions will continue to get better, because no doubt people will continue to move towards coastal areas. Here's a very telling table right here. Look at in the last 100 years, so 1900 to 1909, and then 2000 to 2010, property damage caused by hurricanes. 2.1 billion versus 249 billion. That's over 100 times more in just 100 years. So part of that is due, no doubt, to the fact that more people live near your coastal areas. But I mean, it still is a heck of a lot more money than even just 100 years ago. So putting ourselves in danger is one of the big things that causes a lot of this loss. Okay, so areas that are at risk for cyclones and hurricanes, the way that people respond to the risk really depends on their perception. What if you're a new person that moved into a coastal area that gets hurricane? You may not have that experience, whereas people who do have experience take necessary precautions. You've probably seen this, where people they take their houses and they board them up. They take plywood and stuff, and they put over their doors and their windows and all kinds of stuff like that. That comes with experience. You may not know to do that if you just move there. So the more experience, the more likely you are to be prepared for when these storms come through. Even so, coastal communities do have plans, do have responses in place to adjust to the cyclone hazard. There are warning systems in many coastal communities that are likely to get hit by hurricanes. They get information right from NOAA and then give advance notice. And whether it's fixed sirens on tops of poles or sirens on tops of police cars, the word can get out to quite a number of people that a hurricane is coming, and the people need to either evacuate or take precautions like boarding up their homes. And many communities also have evacuation shelters, so that you don't have to move, out of the, out of the state, or too far away, but you can move just far enough away to be safe, so people don't have to clog the highways with themselves in getting out, but they can go to designated places ahead of time, evacuation shelters in a local area that are secure and that are able to provide for the needs of people in the event of a hurricane. Of course, insurance is a big thing, and it certainly depends on how at risk the area is. That may make insurance cost effective or not cost effective for you, because if it's too expensive, it may not even be worth it. And also building design as well. All right, you want buildings to be able to withstand hurricane force winds. Many buildings around here where we live probably wouldn't be able to do that because we're not used to having those kinds of storms. In fact, many buildings that I've seen at coastal areas still aren't able to withstand hurricane force winds, especially like at the Jersey Shore and stuff, because we don't get hurricanes as much. But down in Florida and in Georgia, in the Outer Banks, buildings need to be built a lot stronger so that they can sustain those hurricane force winds. All right, many homes are actually built up on stilts. So that's not a very good house right there, but that's a house, and you may have seen this at the Jersey Shore actually, but this is much more common, especially in areas that have that are prone to hurricanes and storm surges. That is, houses being built up on, you might say, telephone poles. All right, because you want it to be able to be high enough so the water can pass underneath it in the event of a storm surge. All right, remember, storm surges can be up to maybe 10 or even 15 feet high. I mean, Katrina was 20 feet high, but that was pretty exceptional. But 10 or 15 feet. So you want your house to be built about a story off the ground. Okay, those little doors right there for you. All right, here's a great example. I mean, look at this house right here. It looks like it's built out of concrete. It doesn't have asphalt shingles. No, it has tile shingles right here. It looks sturdy, and even the underneath of it is such where water can flow through and it won't affect the house. So that's a great design for a coastal house that is going to be hurricane resistant. All right, so what can you do to mitigate hurricanes, to be prepared for the hazard of hurricanes and cyclones? Well, first of all, just awareness. I mean, obviously, education is the first step. All right. Well, you want to prepare your home and your property for a hazard. So either build a home like this one right here, or if you don't have one, you can take other steps. Like I said before, you can board up your windows. You can lock down your house in such a way that it is more hurricane proof than it would normally be. All right. Flood insurance or hurricane insurance, if it is cost effective. Shutters. Well, boarding up your windows is kind of like shutters, but many homes have shutters built onto them. I have shutters on my house, but they aren't really functional. They don't actually do anything. They're just for looks. But shutters were actually there so you could close them up and make your house more hurricane resistant. Know where to go if you are told to evacuate. Many coastal cities have signs that tell you which way to go, which way is out of town and to higher ground. But even if you can evacuate, make some sort of family emergency plan. Put things together such that you can ride out a hurricane. Many times that involves having fresh water, because if power goes out and storm surges come in, fresh water becomes scarce. Having emergency radios and flashlights and stuff. So all these things, these emergency supplies, are things that you can do to adjust to the hurricane hazard. Okay, so let's apply all this stuff to Hurricane Sandy, or Superstorm Sandy. Now, this started out as a hurricane. All right, so if I can, there we go, there's a good hurricane symbol right there, and it moved up north and wound up turning into a big extratropical cyclone, kind of shaped like a comma. All right, so that's why we call it Superstorm Sandy. But it really began in the southern Caribbean. All right, it began as a tropical wave. Tropical wave is where you have kind of a low pressure disturbance. All right, and then upgraded to a tropical storm. And it became a Category 1 hurricane just a little bit west of Haiti and the Dominican Republic. And these are, especially Haiti, is a very poor country. And many people, most people, are living in shanties and just kind of patched together buildings right there. So buildings that really are not able to sustain hurricane winds at all. Flooding and mudslides were a problem, partly because in Haiti they've deforested a lot of the country, and so mudslides and mass wasting were a huge problem. And over 50 people were killed in Haiti and the Dominican Republic. Of course, as it continued to move west across the Caribbean, it hit Cuba, and it was a Category 3 by that time. Lots of flooding because of the storm surge, lots of coastal erosion as well, and 15,000 homes were destroyed. So Cuba took a big hit from, at that time, Hurricane Sandy as well. I mean, you can see right here in Haiti that judging from the buildings and stuff and this dilapidated truck, it's not a very wealthy place. In fact, it's one of the poorest countries in the world. And so places like this are especially hard hit. But the problem with predicting where Hurricane Sandy was going to go was the fact that nobody had a good prediction. The NOAA models and the basically all the North American tracks for Sandy were all over the place. That nobody was absolutely certain. In fact, even the Europeans got into it. The European Center for Medium Range Weather Forecasts, how's that for a long name? ECMWF. They were the ones that actually predicted that Hurricane Sandy would hit New Jersey and New York City, which is what it actually did. But a lot of different models. When you hear about models, that means like a computer model, a computer modeling where the storm is going to go. Well, they use various different data, and not all of them agree. And so they were all different, and nobody knew exactly which one was right. All right, so here's the right here is the United States track, or that is the model for Hurricane Sandy, going all the way out into the North Atlantic right here, not bothering anybody. All right, well, all these little points right here are the actual path of Hurricane Sandy, and you can see the different intensities that it has at these different points right here. Well, this was the European model, the ECMWF model, and that was actually a lot closer than any of the models that we had here in the United States. So what does that tell you? And so Sandy was kind of unique, like I mentioned before, in the fact that it was a hurricane that turned into basically an extratropical cyclone. Well, there was a high pressure area, cold air, over Greenland and kind of over the northeastern United States, right? An Arctic cold front right here. And so, let's see, the United States, I'm going to go back here a second. All right, so up in here was this kind of cold front. All right, cold air on this side pushing into warmer air right here. And that did two things. First of all, it prevented westerly winds, that is, winds coming from the west, from blowing Sandy out to sea. But what it also did was had the effect of, instead of breaking apart Sandy, what it did was the precipitation associated with the cold front actually joined with Hurricane Sandy. And remember, it had been a hurricane. It's a symbol for a hurricane. It had been a hurricane up until this point. It actually joined with this cold front right here and produced what we call a superstorm. A lot of times competing storm systems, weather systems can break each other apart, but in this case it actually intensified Sandy as it moved up the coast. In fact, here's an even better, I didn't even realize I had this one. This is an even better image of Superstorm Sandy and the Arctic front. Let's see if I can make this a little bit bigger right here. So here's Hurricane Sandy coming up, and right here is that big Arctic cold front. So right there. Okay, and Sandy actually wound up joining with this and making this giant mess. So hurricane is bringing a lot of precipitation. The cold front is bringing the cold to produce snow. So I'm going to back up here a second. You had a lot of a lot of widespread snow. All right, other places that were warmer, that snow fell as rain, so there was lots of flooding, and as a result, there was widespread power outages all over the eastern seaboard. Part of the problem with when Hurricane Sandy, I should say, hit was the fact that it coincided with the full moon and high tide. Now, if you know anything about the tides, you know the tides are caused by the moon. All right, and a full moon especially makes an especially high tide, and so the water was already high, and then you had the storm surge that came in. Well, New York City was in the front right quadrant, and if you recall from before when we talked about storm surges, that's the area where you're going to have the highest storm surge. So New York City got a lot of water, a lot of flooding, a lot of power outages, all because of the storm surge that came in because of Hurricane Sandy. Some people were evacuated in New York City. I guess they have it broken into various different evacuation zones, zone A, B, C, D, and E, etc. But only that one zone evacuated people. But even so, the hurricane Superstorm Sandy was still pretty strong, even though it didn't have hurricane strength winds when it came ashore. It still brought a lot of water with it and produced a lot of flooding in New York City and in New Jersey. So this is probably kind of hard to see, but this is our evacuation zones and flooding areas, and the flooding area is the red right here. All right, so all this was flooded. Look at this peninsula right here. The whole peninsula was flooded. Rockaway Peninsula. Staten Island I'm very familiar with, and even lower Manhattan right here and parts of the Bronx. And in fact, every single borough, it seems, of New York City was flooded to some degree. Let me see if I can actually make this a little bit bigger and do that. There we go. So maybe you can see it a little bit better, but a lot of flooding in one of the most densely populated areas in the country. So just as a quick recap of Superstorm Sandy, what are some of the effects that it had? Well, the storm surge was a big one. It brought a lot of water into a very highly populated area. There were seawalls in place that it still crested those seawalls and went over. The states on the East Coast are a lot smaller, and so they're a lot closer together. And so 16 states were all affected by Superstorm Sandy. And a lot of power outages and a lot of destroyed homes and a heck of a lot of flooding and even some snow. Because remember, a cold front came in there. And I mentioned already the flooding that was associated with Superstorm Sandy. And all the various different homes, and I think you may have seen the roller coaster that was on the Jersey Shore that was out in the ocean. So a lot of damage done by flooding and the heavy rains. Because what New York City looks like in the event of a blackout, it's not a complete blackout because a lot of buildings have backup lights, but it's pretty darn dark compared to the way it usually looks on a typical New York night. All right, so in the future, how can we cut down on the effects of storms like Superstorm Sandy on places in New York, like New York City? Well, what it means is that there's going to be even a higher insurance costs. So it may not make it cost effective for somebody to want to live in certain coastal areas. Government buyouts. That's kind of nice. So if you have a parcel of land that was totally destroyed, what you were offered is they would offer you the cost of your land before the storm. So even though it was everything was destroyed and the cost of your land has dropped, they'll give you full value for it because they want to make sure that land it's not built on again, that it can be put to other uses that actually prevent the damage from hurricanes like this. You can turn these into parks or wetlands, things that actually serve as buffers between us and the elements. And in the next picture I'm going to show you, and it's the last picture, storm surge barriers. But the question is it too expensive? So these are barriers that can be moved in and out and actually serve to prevent storm surges from coming through, almost like valves. So take a look at this and see if you think this would actually work. All right, so this is a moving what these things do is there's a pivot there and a pivot there, and that swings that way and that swings that way. So of course boats and various different things can get in and out. But in the event of a storm surge and a hurricane, these things are swung shut, and so get rid of that right there. I'm sorry, and so that it prevents a storm surge from going any further inland. It looks like it might be effective, and looks a lot like a heart valve, if you ask me. But the question is, does it cost too much for the likelihood of a storm like that to happen again? Well, that's a question we need to ask ourselves, and that's why we're studying this. So this is our the last bit of our chapter on hurricanes. Thank you for bearing with me. This has been a long section right here. But if you have any questions, please make sure you see me, and I'll see you on the next one.